Each axis does a separate motion. We can take a look at it next. First, power on manually. After power on, we can press these buttons. This is axis AE moving. That's AR, axis in motion. This is AC in motion. This is AC, axis in motion. This is AU, axis in motion. That's ADO in motion. Our welding gun is installed on the ADO axis. You just saw it. I press the button of one axis, which means one axis is moving. The characteristic each of the axis does a separate motion. Under what circumstances will the axial coordinate positioning be used? Use the axial coordinate system. Quickly get the robot to reach a certain angle and a certain axial coordinates are the fastest. The second is called the world coordinate system. When I switch to the world coordinate system, 12,356万 it will become X, Y, Z and A, B, C. So what about when you see XYZ? More familiar. World coordinate system called the Cartesian coordinate system. What about this time? The robot is programmed to move in a horizontal plane, and is directional. So how is it stipulated? When I stand facing the front and rear motion direction of the robot is the X direction. The left and right motion direction is the Y direction. Of up and down motion is the Z direction. A, B and C rotate around the three axes respectively. C rotates around the X-axis. B rotates around the Y-axis. O rotates around the left and around the Z-axis. So let's take a look. First I press the X positive direction. It should be moving in my direction. Press X positive direction. It just moves forward as a whole. It moves in a horizontal plane. X backwards motion. Then the Y positive is direction. A movement to the right. Y negative direction is movement to the left. The positive direction of Z is to move negative up. Direction is downward motion. This is the direction ABC of XYZ. So let's look at C rotating around X. B rotates around the Y-axis. O rotates around the Z-axis. Under what circumstances will the global coordinate system be used? As you can see, at this time, the robot movement is directional. So when it comes to precise positioning, we can use the global coordinate system. Because, for example, we are in the welding process. Come down a little bit, which is the negative direction. To the left is the negative direction. Of forward is the positive direction. This time it is directional. ABC when we weld. When adjusting the angle between the welding torch and the plate, very convenient to use. Okay, now that we understand the coordinate system of the robot. Robot welding, plate butt weld. First I need to prepare the welded plates. This is the plate we want to weld. It is 3 毫米 low carbon steel plate. We start by placing the panels on the workbench. Because during welding, the plate is locally heated and there will be welding deformation. So we're going to fix the plates. Using the platen on the workbench, press the plate onto the workbench. When the plate is placed, also pay attention. Align front and rear. Don't misplace up and down. No gaps in the middle. Fix it up. When ready, we can then weld into. First, create a new file. Click the heart of the menu bar. Click the menu bar OK. We'll jump out of the keyboard. Enter our file name file. When typing, note that the first character must be a letter. So we can enter Han. Pick up. Press enter after the input is complete. After pressing enter, our newly created program will be marked in blue. So, how to enter our program? Click the menu bar to select. It will enter the programming interface of our program. Coming in, as you can see, he has 1353 programs. Then the first line. We don't need to worry about internal automatic inspection. 3&5 P2P home speed 100%. These two are exactly the same. It's the robot starting from scratch. After the work is done, we have to go back to the starting point. Has to insert between C and U. Do not write the program before the third line, or after the fifth line. This doesn't work in automatic mode. Okay, what do we do? So first of all, click on line 4. A cursor will appear. What about after the cursor appears? We click the menu bar action. It pops out of a one-liner. What does that mean? Let's first look at the first box showing P2P. It also has a drop-down arrow, and there is also P2P in it, which means point means straight line, neck means curve. These three, we can write all our trajectories. Suppose I'm going to start him off on a P2P scale. Move to a point P. I click P2P. Click on the picture. We can operate it. The robot first makes him come down in the negative direction of Z. Y negative direction to the left. X moves forward. Okay, I'm going to start with the robot. Move to this point. I'm going to tell him to document this. How to record. I click the menu bar to determine the parameters. He will ask whether to accept this as P is. When you're done, click the menu bar command OK. Then this line of program is written. It means moving from the initial point in the form of P2P to the PE point. Now we're going to move. What about this time? We choose a straight line. We operate the robot to continue to move down. What about welding? It is necessary to make the welding wire and the surface of the plate. So we're going to keep going down. Adjust to the position where welding we can starts. Record that point again. Same as before, make sure the parameter is specified OK. Then we have the next second point written. This is called dry running. Next we're going to weld on the plate, so it's called welding programming. Click on the menu bar to command Arctic Arc Control. Archon. Tell him to start soldering here. What about after just touch up the command OK? It will record. Turn on the arc from this point and start welding. So, what happens to next? Continue welding. Let the robot start soldering from the starting position. Move to the end soldering position. This is called welding programming. We switch to continue welding. What about welding? There are two forms. One is linear welding. It sucks. It's curved welding. It's called a plug. We are welding a straight line. Click straight. After clicking on the straight line, keep the robot moving. Power on first and move forward in the positive direction of X. Move to an solder position. Front, rear, left, right, up and down can be adjusted. OK. OK parameter instruction. What about after he welds it at this time? And give him one more instruction. Tell him to turn off the arc. Order can be closed. OK, parameter instruction. After turning off the arc, you also need to let the robot leave it first. Go back to the starting point. So, keep him at a safe distance from the surface of the ball and arrow. Click the action in the positive direction of Z. Power on first and press the positive direction of Z. Lift it up. Lift further than the blue handle. Just do it. OK, it's the instruction. OK. So this is our live demo. Write a tablet docking program. OK, what about after it's written? We're going to manually check the program. The purpose of testing is to see if the program is written correctly. Second, look at the robot and other obstacles on the workbench. There will be a collision. So what do we do? Let's run some tests first. What about testing? First, reset the program. Where there's a capital number in the status bar on the capital letter R. There are two options when you click on it. One is to cancel the program selection. One is program reset. To cancel a program option is to exit the current program. Reset is to return the cursor to the first line. What about after going back to the first line? To return the robot to the starting point position. How to return to the starting point? Press the power button first. Then press the left side of the screen. The false green triangle symbol. Keep pressing it. This is the program start button. The robot will automatically return to the starting point. It will automatically stop. And when we stop, we let go. Release and then power on. Keep pressing the start button. The robot will move. We can take a look. Follow the trajectory we just drew. Moving. First move from the initial point to the P point. After moving to the P point, go down to the position where the plate starts to weld. Then move forward on the board. It's the welding process. OK, he checks the welding and then lifts it up. Return to the starting point. In manual mode, or power button and program start button, keep pressing. Don't release until the robot comes to a complete stop. OK, no problem after the test is completed. We can do automated welding next. There will be arcs during the welding process. So we need everyone to protect. Then everyone can be on the table next. Get the prepared welding mask and then watch the soldering. The first is to turn on the control arc button. Click the third one. Press to switch to automatic mode. Click Alt to switch back. What about after switching back? Letter R. Program reset. After that, check that the automatic operation rate cannot exceed 10%. So let's reduce it to 10. After reducing to 10, we can proceed.